Hi, in this video I will tell you what is a constraint optimization. I'll start with explaining what is a constraint and then how we show it, and after that I will tell you what do we mean or how constraint optimization is different than the regular optimization. Okay, so let us start with this question. What is a constraint? Well, when you work with any problem, doesn't matter optimization, anything, sometimes you're not interested in all possible points, all x and y's. So you want to restrict your points to points whose coordinates satisfy a relation. That relation is called the constraint. So um, a constraint is a relation between x and y coordinates of the points um, under the investigation. So we are not interested in doing something for all x and y's. We are interested in doing uh, points whose x and y have some specific relation. But how do we write this relation? So the relation is given by an equation in x and y. So if you have an equation in x and y, that's basically a constraint. For example, you can say I'm interested in points whose x and y satisfy this relation. X plus y is equal to 1. Or x squared minus 2xy equals to y cubed plus 3. I'm interested in points whose x, y coordinates satisfy this condition or this condition. Well, let us just fix something right away here, and that is when you're trying to put a condition, a constraint, there is a form that I will call it standard form of a constraint, which is, well, any equation someone gives you, you can bring all the variable, all the numbers one side and write it as g, x, and y equals to 0. So every single equation in x and y can be written like that. For example, the above examples, you can say in the first one, I have x plus y minus 1 equal to 0. So in this constraint, gxy is basically x plus y minus 1. Or in the other one, you can write x squared minus 2xy minus y cubed minus 3 equals to 0. So in this case, that gxy is this x squared minus 2xy minus y cubed minus 3, and we always try to set everything equal to 0. So we'll get back to that and we will see how we can work with this. But there's one more thing that I want to add to this video, and it is um, how is a constraint optimization different. How is it different? Well, in the regular optimization, so this is just optimization, all right? Optimization, regular one versus the constraint optimization. Optimize. So regular optimization, basically what we are interested in find extreme value of a function f of x, y. Well, what we have done is not really the extreme. What is it is? It is relative extreme, relative mean or max value of f of x, y. But in the constraint one, we are still interested in finding extreme value of a function f of x, y. But we are not just interested in that. We want to restrict our points x and y to a condition, to a constraint, subject to a constraint. Before, in the regular optimization, you have only one function and you want to find its extreme values. But here, you have one function and a constraint, sometimes more than one constraint, but here what we are interested in only one constraint. Let us see this in an example. In an example, one can say, well, find minimum value of a function like f of, I'll do an example, just f of x squared plus y squared. But on the other side, you can say, well, I'm interested in find mean value of same function, but constrained to something, subject to let's say just the condition we had before, x plus y minus 1 equal to 0. Yes. So when you're trying to find the mean value, the regular optimization, what you do, remember the steps. Find the critical point. Well, in this case, it is 0, 0. And since we are looking for relative max, mean in this case, both of them matches, but we use the test, and we see that f at 0, 0, which gives me 0, is the relative mean of f. But when there is a constraint, then you cannot use the method. Basically, we cannot do anything with this. There is no tool, and this is a big no. The test does not work. So we are looking for a method that we will learn in the next video. But let me just, for completeness, try to solve this constraint optimization just by an easy optimization. See that x plus y minus 1 equals to 0 means that I can write y as 1 minus x. And basically our problem is find minimum of f at x, any x you like, but y needs to be given by this condition. So I'm interested only for f of 1 minus x's. So it means that I'm looking for minimum of x squared plus 1 minus x squared, which if you simplify, you'll get 2x squared minus 2x plus 1. You see that the constraint, what did constraint do is that turn our minimization of function with two variables to a function with one variable. And for one variable, in this case, I know that its minimum happens at x equal to minus b over 2a, which is 1 over 2, and mean value is when x is 1 over 2, so it will be 1 over 2, 1 minus 1 over 2, and if you do plug in your function, you get that 1 over 4 plus 1 over 4, which is 1 over 2. So you see, we were trying to minimize same function, one without constraint, one with constraint, and their minimum are completely different thing. And this shows right away, this easy example shows that, well, uh, constraint optimization is a different story, and well, you need to develop some new tools. The method I used here was possible because the constraint was easy. I can write the constraint using constraint. I can write one of the variables in terms of another one, and then turn my function to function with one variable and do it. But in general, it is not possible. In general, what is possible is a method called Lagrange multipliers. In the next video, we will do Lagrange multipliers, and I'll tell you in details how to optimize a constraint function.